Hello! This is the fifth video in my build log series for my VR shoe. If you're new here, I am trying to make a motorized shoe to be used with virtual reality games. I'm using 3D printing, CNCing, 3D modeling, as you can see, related technologies to do it. If you want to watch the other videos in this series, I'll leave links to those videos in the description. In this video, I design and test out the part of the shoe that attaches to the user's foot and allows the user to lift their foot and walk like normal, but in such a way that the shoe follows the user's foot but stays on the ground. And during that testing, I ran into a few quirks, but quirks that are easy to overcome, as you'll see. So let's get started. To get started, I'll show you the design as it looks like after I got done with it this week. The green parts are the parts that I added in the for this video since last week. So this part here, the binding, as I call it, is where your foot goes. There are holes, as you can see, to put straps in so that you can strap your foot to this piece. And then right here there are some holes so that you can put a strap around your ankle. And what happens is once you are strapped in and you lift your foot, you can see that the binding is attached to this piece here. This piece will come up and slide along these two rods here. So it will look something like this. I have a video later on showing what that looks like after all the parts are made and assembled together, but we'll get to that in a minute. I just wanted to show you what this looks like in the design view in Design Spark Mechanical, and then show you a little bit of the process of making it. So here is the first part that I 3D printed. It's 3D printed out of flexible filament TPU. You'll see later on that making this part entirely out of flexible filament was a bad idea, but I will explain that in a little while. But this piece and then this piece back here are the first two parts I made. You can see here that the binding, it's only half the binding. I don't have a printer big enough to print the whole binding as one piece, so I split it up, and then where I cut it, I put a dovetail joint pattern so it would be easy to attach the two pieces together. Okay, and then in the background you can see I have the two linear bearings that I need, and then this long hex bolt will connect the binding to the slider part that will be over here. Here are the two rods that go back here, and then here are a couple of the end stops that keep the rods and the slider in place. Here is the part that slides along the two rods. The linear bearings are partway into the piece. And then here is what it looks like when the two linear bearings are hammered completely into the piece. And here's what it looks like with the piece on the shoe, and the rods and the end stops all in place so that this slider will slide along the rods. It didn't slide very well at first, but all I needed to do was put a little bit of grease on these two rods, and it started to slide very, very easily. And then here's what it looks like with the rest of the pieces done and everything just put together. The front piece, as you can see, is like I said, the binding pieces just go together via the dovetail joint pattern. That pattern made it very easy to put the pieces together. And here is what it looks like from the back, just another angle. Here are the Velcro straps over here that I use to secure my foot to the binding. They're just Velcro straps that I bought from the store. And then lastly, I'll explain how I cut these two rods because that might not be obvious to some people. So I just went to the hardware store and got a long 5/16 inch rod, and then I used a hacksaw to cut it. To secure the rod in place, I 3D printed these two rectangular pieces here a long time ago, and you can see that they have some holes in here for different size rods. This one is for 5/16, this one's for 1/4 of an inch, this one's for 1/8 of an inch. And what these pieces do is they allow me to hold the rod in place and give the clamps a flat spot to clamp down really well and hold the rod really well. You can imagine if these pieces weren't here and you tried to clamp to just the rod itself, since it wouldn't work very well. The clamp would just slide off the end of slide off the side of the rod because it's not flat. So just wanted to show you that in case anybody needs a good way to hold a rod in place to cut it. Like I said, I just used a regular hacksaw to cut it after that. And that's it for the slideshow. The way this works is your foot will be strapped into this thing. There are holes, as you can see here, 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 and then right here. There are holes for straps, so you put your foot in. You can use straps to secure, then use straps to secure your foot into here. And then if we look at the back, you can see there are two rods here, and there are two linear bearings, so you can lift your foot up when it's strapped in there. This right here also pivots, so if you lift your foot up, you can pivot your foot. This whole thing is printed out of flexible filament. That actually ended up being a bad idea. Not all of it should be flexible, but you'll see that in a minute. It's based off of an older design. So you can see I have a wooden platform, something similar, and then the strap would go through this thin hole here. And then there are two linear bearings that would go through rods like this. An older design. And this is updated. But like I said, using flexible wasn't a good idea. And that's really how it works. So when you're strapped into this and you want to take a step forward, you'll naturally lift your foot up like this, and then as you lift your foot up, you'll bring the whole shoe forward, but the whole shoe doesn't come off the ground, only your foot does. And then you put your foot down, motors will activate, bring you back, then you'll lift your foot up again, bring it down, and it'll bring you back. After all of the parts were done printing and I assembled everything, I tested it out. Here's a video I took of it. So first, I strapped myself in. You can see I used the Velcro straps. It took me a little while to strap myself in. I want to improve on this, make the binding better and easier to strap in, but for now the Velcro straps are fine. And then once I was strapped in, you can see I can lift my foot, and this whole thing slides along the rods. I can pivot my foot, and then here I go. I take a step, and then the shoe will bring me back. Take a step, motors activate, bring me back. You can see that the shoe is kind of going off at a weird angle. That's one of the problems I ran into, and it's kind of wobbly. It hops a little bit. I'll talk about that in a minute. But I hope this gets across the basic idea of how your foot will be strapped into this binding, and you can lift your foot up and down and pivot it and pretty much walk like you would normally. As you can see here, I take a step and then I would bring my other foot forward. So take a step, and then bring my other foot forward, and then the other one will come back. So I hope you get the idea. that you can lift your foot up and walk normally, and then the shoe just comes along for the ride. Just stays on the floor, follows your foot wherever you go. Okay, that's the idea. Here is what the testing looks like from another angle, from top down. You can see the problem where the shoe goes off at an angle, but I just want to show you what it looks like looking at it from the top, looking at it from more of the user's perspective. Here's another video showing it from the top point of view again, but this time I put the shoe alongside a filing cabinet just to keep the shoe from pivoting and to show you what it's supposed to look like where the shoe stays straight, comes along with your foot. You can see there's a bit of a wobble, a lot more than a bit, but there's a wobble. I think that's another issue that will be easy to solve too. So as you saw, there is some flex where this leg attachment or foot attachment, the straps, it can flex like this. So when you bring your foot up, the whole shoe pivots out in this direction. As you saw, if I would use solid filament instead of flexible filament, I think that would solve the issue. So solid on the base and for this part. So I'll have to redesign this to have some solid filament parts and some parts that are still flexible. The other problem that you may have noticed is this thing will rock like this, because when you bring your foot up, there's no weight on this side, so all the weight is over here, so the shoe wants to tip like this. So if there's no weight on here and you're going forward, it was going like this kind of. The way that I want to resolve that is to just put some ball transfers on this side so that it can't tip down like this. So so like these ball transfers, but put a few small ones over here on this side. Okay, so those are the issues with it, but the concept I think is sound. This type of design will work, just need to make a few tweaks to it. And that is it for what I did this last week with the project. To summarize, this next week I'm going to update the design for the binding to use some solid parts and some flexible parts to try and solve that pivot problem. There's also another thing that I thought of while I was making this video, I should say editing this video, that I'm also going to try. And to solve the problem where the shoe rocks back and forth, I'm going to use some small ball transfer units. I'm going to 3D print them, use some BBs for the small balls that go into the ball transfers, and then I have some larger balls to use for the main ball in the ball transfer. So you guys will see that coming up here in the next video. Okay, and just a general question. I feel like I do repeat myself or repeat explanations a couple times, maybe more than necessary. If you guys feel like I repeat myself more than I need to, then let me know. I just want to make sure that I explain everything well enough so that everybody can understand how the design works and what's going on. But let me know what you guys think. And then I wanted to just talk about the immediate future for the project. After I get those little issues with the binding and the rocking, that stuff, after I get that done, I'm thinking I'm going to get a battery, some LiPo battery, and I'm going to hook it up to the motor, and I'm going to just use the shoe for maybe 10 minutes and then see how much it drains the battery, and then I'll multiply that drain by 6, and just to get an idea for how much power it needs, how much it actually drains the battery in an hour, get a real life example a real-life measurement of that, so that I can determine if it's feasible to use batteries for this thing, if batteries are going to be affordable enough, if you're not going to need to buy a whole bunch of batteries to use this thing for, I would say I'd like it to last at least 2 hours on a charge. So maybe batteries will be an option, maybe not. If they're not an option, then hooking it up to a power supply is the other option, but that comes with its own difficulties because you have to hook that power supply into a wall, and when you're using the shoe, you're going to be turning, doing every which way, and the wires might get tangled up around you. So I would like to use batteries. We'll see if that'll work. I think it'll work, and we'll see. And then you might have noticed that the ball transfers that I'm using are loud. When the shoe is moving, the ball transfers are really loud. I'm going to try using quieter ball transfers. The ball transfers I have now use steel balls. If you use plastic balls like nylon balls, it's quieter, but there's a bit more friction, so there's a trade-off there. I'm going to have to experiment with that. I want to make the shoe overall look better, so I'll be fiddling with the design to make it just in general look cooler, and then of course I need to program this thing. It needs to know how fast to move your foot back, it needs to know when to move your foot back, so I'm going to be doing some programming and using an Arduino and an accelerometer to control the motors to turn them on and off. And then also I may do some videos on some older designs that I had. Like I mentioned in the first video in this series, I have many older designs, many ideas that I had for getting this thing to work, but they ended up not working out for one reason or another. But I think it'd be good to share those designs so that other people can learn from them. And then that's it for the immediate future. So if you have any questions or comments, feel free to leave them below. And if you like this series, you can feel free to leave a like on the video and subscribe if you want to see more. And just thank you for watching. I really appreciate it.